Okay, this next video is about multiplying, dividing and simplifying surds, which kind of looks at exercise 12.2 in your textbooks. So imagine we have the situation where we have the square root of 3 multiplied by the square root of 5. Now we can actually join those two things together because they're both the square roots. We can actually say that it's the square root of all of that. It's the square root of 3 times 5. And now that we've got it all under the one square root, we can actually say that that is equal to the square root of 15. Or conversely, we can go the other way. We can say that if I have the square root of 22, that can be the same as the square root of 2 multiplied by the square root of 11. So I'll do it in one more step. I know you can probably see that, but it's the square root of 2 multiplied by 11, which is the square root of 2 multiplied by the square root of 11. We can go actually both ways with that. Most commonly we do the one in the red. We go from splitting the 2 up down into this one, but there are occasions where we do that one as well. Let's just imagine that I've got one more situation. I've say got the square root of 20 and I want to know what that is. Well, that's the same as the square root of 4, I wrote down the next one, square root of 4 multiplied by the square root of 5. Now we also know that that is the square root of 4 multiplied by the square root of 5. We also know that the square root of 4 is in fact just 2. Not plus minus 2. I know some people get a little bit confused with that, but there's only the plus minus 2 if you've actually done the square root to something. So for argument's sake, if you had x squared equals 4, then x can equal plus and minus the square root of 4. But in this case, we're not dealing with that because we've already been given the square root and the square root was already positive. Little sidetrack, but I think it might be helpful for some people. So the square root of 4 multiplied by the square root of 5. It doesn't matter whether you write it like that or whether you write it like this. It is different though than this. Okay, so the 2 is actually multiplied by the 5, not up here above the square root. That there means, I guess that means the square root of 5, but you can imagine there could be another situation where you've got, say, the cubed root of 5 or the fifth root of 5 or whatever else. But here it's 2 multiplied by the square root of 5. I'll just rub that out because that's not as relevant right now. So the square root of 20 can be written as the square root of 2 multiplied by the square root of 5. Now this kind of takes me to simplifying surds. We'll come back to multiplying in just a second, but the next thing I want to look at is simplifying surds. Because what we just did was in effect simplifying the surd from root 20 to root 5. Generally speaking, we always prefer, instead of writing the square root of 20, we always prefer to write 2 root 5. Or, for example, if you've got the square root of 50, we always prefer writing 5 root 2. Now I guess the question you're probably asking is, how did I get from the square root of 50 to 5 root 2? Well, this is where I come back to the numbers that I asked you to write down before. These ones up here. The numbers from 1 to 10. You could write all of the rest of them, all of the numbers in the world actually, but I prefer just using numbers from 1 to 10. We won't usually ask you many more numbers after that. And then the square roots of all of those. So the process of simplifying a surd, you need to probably have that written down there somewhere so that you can see it. I would encourage you to write at the top of each page you write, and as soon as you get into the test, write it at the top of your page as well. So let me start with something like, let's start with that one there, the one that I've got. The square root of 50 is the same as, now if I'm trying to simplify it, I need to think of a number up the top, so one of these top numbers that divides evenly into the number we had. I had the number 50, so obviously it's not going to be 181, 64, 49. That's not going to divide evenly into 50. In fact, 36 isn't going to divide either. It's fairly obvious now that 25 actually goes into into 50. So what we can do is we can actually write it like this. It's the square root of 25 multiplied by whatever number that I needed to multiply to get to 50, which is in fact 2. And that is the square root of square root of 25 multiplied by the square root of 2, which is 5 root 2. Okay, let's try another one. Let's try the square root of 18. Again, I look up to the top and I find a number that goes evenly into 18. It's clearly not going to be 16. It is in fact 9. So that becomes the square root of 9 multiplied by the square root of 2, which is 3 root 2. Now let's try another one. Imagine I've got the square root of 28. Again, I look up at my numbers. Square root of 28, where is that? Well, 25 is not going to go into it. 16, no. 9, no. 4 is going to go into it. We always try and go to from the top. I'll show you an example later on why we do that. So that is the square root of 4 multiplied by root 7. And that becomes 2 root 7. So that's how we simplify surds. We choose a number up the top, then we multiply it with whatever other number to get to our total surd, and then we do the square root of that number to get our final answer. Now, you can actually go the reverse as well. I can actually make 3 root 2 back up into the square root of 18. What I'd do is I would square 3 to get to 9, and then I would multiply the 2 square roots to get to 18. If you're having troubles understanding that, then maybe ask me about that a little bit later, but you can do that as well. Now, I mentioned before we always go from the highest number. So each time I always went from the top. I went from 100 and I went down. Let me show you an example why that's useful. For the next example, I'm going to show you one where I'm not going to choose the highest number. I'm going to start with the square root of 32. Now, I'm going to deliberately choose a number that's not the highest. So I'm just going to go from the lowest now. I'm going to actually try this one, root 4. So that is the square root of 4 multiplied by the square root of 8. That's 2 root 8. But if I look at root 8, I can actually simplify that again. If I look at 8, a number that goes into 8 is in fact 4 again. So this becomes 2 multiplied by the square root of 4 times the square root of 2, which is in fact 2 multiplied by 2 multiplied by root 2, which is 4 root 2. So I actually had to perform the process twice. Let me show you how I could avoid that. If I had the square root of 32 and I chose the highest number, in this case, which is root 16, it becomes root 16 multiplied by root 2, which very easily becomes 4 root 2. A much simpler step. It's probably a little bit harder dealing with higher numbers, particularly if you've got 4 or 5 times these. 4 or 5 times 49, for instance, would be quite challenging. But still, it's much better to use the highest number possible. But you don't have to. You can, in a test or somewhere else, you can actually use a smaller number, and you might just have to do it 2 or 3 times. If in a test you stopped at, say, this point here, you would only get 1 out of 2 marks. You do need to go the whole way and simplify it as much as possible. So that's how we simplify surds. Okay, now I want to talk to you a little bit about dividing surds. Dividing surds, here we go. Okay, so imagine we have the square root of 26 divided by the square root of 2. That can be written just like with multiplication. We can actually put it all under the one square root. That can be written as the square root of 26 over 2. And we all know that 26 divided by 2 is actually the square root of 13. If you like, there's another step in there. It could be the square root of 13 over 1, which I guess is the square root of 13 over the square root of 1, but I'm just going to write it as the square root of 13. Let me give you another example that sometimes is a little bit more helpful. Possibly the square root of 4 over 3. That can be written as, this is probably going the opposite way now. That's the square root of 4 divided by the square root of 3. Okay, this time we're splitting it up rather than going from that way. And that becomes, the square root of 4 is just 2 over the square root of 3. And so this can be really helpful. I guess dividing surds like this, 26 divided by 2, can become root 13. But it also is really helpful the other way, because we can actually identify that the square root of 4 is actually much simpler than the square root of 2. Where is this applicable? In our last topic, when we did completing the square, sometimes you guys got an answer of the square root of 3 over 4. And in the answers in the textbook, it might have said something like the square root of 3 over 2, and you were unsure as to how that got there. This is kind of where that all comes in, because the square root of 3 over 4 is the same as the square root of 3 over the square root of 4, and the square root of 4 is in fact 2. So that's kind of where it all sort of links in. Let me show you one more example of dividing surds. And let me just give you an example of, say, root 60 divided by root 3. That becomes root 60 over 3, and that is the same as the square root of 20. Now I have to think to myself, every single time I do a multiplication of surds or a dividing of surds, I also have to think about the thing that we were doing before, which is simplification of surds. So I get to root 20 and I think to myself, does a number up the top go into that evenly, and then I can simplify it? In this case it does. The number up the top is the square root of 4, I've already done this one before, multiplied by the square root of 5, so this becomes 2 root 5. So again, the answer in the test is not root 20, the answer is actually 2 root 5. So you need to do this one to get the full marks. Okay, the last thing I want to do is show you just a couple of tricks when multiplying and also dividing surds. Imagine you've got a number out the front here, 2 root 3 by root 5. We always multiply the square roots together, but we leave the numbers out the front. So for example here, the square root of 3 is multiplied by the square root of 5 to become the square root of 15, but the 2 isn't multiplied by anything. Okay, so the 2 is, I guess the 2 is multiplied by the number in front of here, which is 1, but it's just root 3 times root 5, which is root 15, and the 2 is left out the front. Okay, so sometimes that can be a bit tricky. So people want to multiply the 15 by 2 as well and get root 30, but that's not what we do. Let me show you another example, but a little bit more complicated. 3 root 2 by 5 root 7. That becomes, we multiply the surds on the inside, so that it becomes root 2 times root 7, which is root 14, and then we multiply the numbers together. So 3 multiplied by 5, which is 15. So we multiply the numbers together and the square roots together. We don't sort of mix and match those two things. Now, if we're dividing 9 root 6 over root 3, again we do the numbers in the square roots, we divide those together, and the numbers outside the square roots we divide as well. And there's always an invisible one or a secret one there as well. So that becomes 9 over 1 multiplied by root 6 over 3. Now root 6 over 3 becomes root 2, and 9 over 1 just becomes 9 as well. So that one simplifies down to 9 root 2. The last one I want to show you today is 10 root 15 over 5 root 5. It'd be really tempting at this point to kind of cancel out all the 5s, because there's lots of 5s there, and do it that way, but that wouldn't be so helpful for us. We do the numbers first, so 10 over 5 and root 15 over 5. That becomes 10 over 5 by root 15 over 5. That becomes 10 over 5 is 2, and root 15 over 5 is 3. And the very last thing I want to say to you guys is that you always need to simplify. Okay, whether you're multiplying, dividing, even later on when we do adding and subtracting, you always need to simplify the surds.